Here we are at Oregon State University at the NSF Marsam Geotech Repository. Let's go inside. Here's where they keep all the samples for samples of cores around the world. These ones here are from Russia. Come on! These samples here are from us at University of Washington.
Each of our samples stored in the repository cold room had to be split and subsampled. Here we see Evan placing a PVC pipe along the track for a gravity core collected in the Astoria Submarine Canyon in March earlier this year. Gravity cores are typically 10 meters in length and need to be split into multiple sections for ease of transport and storage. In splitting the core, Evan turns on 2 rotary saws to cut through the PVC and guides the blades along the track. This is a very loud and messy part of the process. This core was collected from a depth of 800 meters. Once the cutting has been completed, he moves the core off the track and onto a table. He clamps the core to keep it stable and uses a carpet knife to slice the caps. The MGR staff warned us to be careful with the knives as they are very sharp. Here we can see an example of this as Evan cuts his thumb. He then takes a wire and uses it to separate the 2 halves, running it along the length of the core. Here we can see Evan putting his thumb in his mouth like a little baby. Now it is time to see what's inside. Evan masterfully removes the mud that is sticking to itself. This mud has likely not seen the light of day for several decades. Wow, look at that laminated turbidite. Next, we create a digital image of the core by running it along a track. The rest of the process involves incrementally sampling the core, bagging, labeling, and storing the samples to be later used in lab work and data analysis. This is a good example of one of our better attempts at a clean sample collection. Each bag is sealed to prevent it from drying out. That's all for our visit to the MGR repository. Thanks for watching.